Okay, in this lesson we're going to be finding the domain from just the equation, not looking at a graph. So before we start, I want to kind of do a little bit of review with you about factoring because it's going to be really important as we look at domain. So if I look at this equation and I'm just looking for factoring, factoring means dividing, right? So if I look at these two terms, how can I divide, or what can I divide out of both of them? Well, that would be the greatest common factor. So notice they both have an x, so I can take an x out of each term and then divide out an x would leave me with a 2 and an x plus a 3, right? And I can check my work because if I mentally multiply them back out, distribute that back out, I come up with what I had. But what if it's a trinomial? Remember something with 3 parts, an expression with 3 parts? Trinomial. So maybe you remember these, maybe you don't. But when you factor, you ask yourself, what multiplies to the last term, but adds to the middle term? Okay, what two values multiply to the last term, but add to the middle? So you think about the factors of 15. You got 1 and 15, you've got 3 and 5, and those do add up to 8, so that works. So as long as this value right here is a 1, which it's probably going to be today, we can then write our factors. It'll be x plus 3, I got that right there, and x plus 5, I got the 5 right there. Okay, so that's factored. What about this one? What two numbers multiply to 1 but add to -2? Well, only numbers that multiply to 1 are 1 and 1, right? But to be -2, they would have to both be negative. As long as they multiply to be a positive, it works. So it can be x minus 1 times x minus 1, and we could also write that as x minus 1 squared, right? Either one is correct. Now that that's refreshed in your mind, let's look at the next thing. Okay, so let's look now at these functions. When I'm thinking about domain, what is domain, member? It is the x values, right? The x values of the graph. So let's think visually. You're not going to have a calculator to check this. You got to think. Okay, so 2x plus 3. Well, what kind of graph is that? Well, x is to the first power, so it's just a line. So what x values are used with a line? Well, there's no break. It's continuous. So it would be from negative infinity to positive infinity. So you'd say domain equals negative infinity to positive infinity, and we would box our answer. I didn't do that earlier, but I should have boxed my answers. All right, what about number 5 here? 3x squared minus 5x plus 1. What shape is an x squared? Well, that's a quadratic, isn't it? That's a quadratic. Now, although it has a minimum, we're talking domain here. What x values? So think about your x values. There's no break in the x values, so my domain would be all real numbers, or negative infinity to positive infinity. Now the logarithm function. Do you remember what the logarithm function looks like? It looks like this. There's a big old asymptote right here, and this one is just moved up 7, so it's going to do this guy. Logarithm has an asymptote, so it doesn't exist over here at all. So it only exists from 0 to positive infinity, but it really is not even existing at 0. It's an asymptote there, so it's 0 to positive infinity. So this is where knowing your parent function is going to be super important. Since you don't have a calculator, you got to know these. Now what about the greatest integer function, x minus 10? So remember with our domain on the greatest integer, do you remember what that looked like? Has a little stair step. We said every single x value is used, but there's breakage in the y's. Okay, there's gaps in the y's values, but the x values are all used. So just because, what is this doing here? This is just moving it to the right 10. That's not changing any of that domain. So it's going to remain the same. The domain would stay from negative infinity to positive infinity. All right, so we're still doing domain from an equation, but let's talk about rational functions. So if you don't recall, this is what that rational function looks like. It's the two L's with the asymptotes with the breakage, right? And the reason that breakage happens is because x is in the denominator, and you cannot divide by 0, right? So any value we put in for x that makes this makes a 0 in the denominator is going to cause an asymptote all right? So while you're not going to have a graph, you need to connect this picture to this equation so you can visually get there. So let's look at number 8 here and just see what happens. So if I look at this equation, I notice, first off, there is an x in the denominator. This is a clue it's rational, right? In all these equations we're going to do, there's an x in the denominator, and that's really all we care about. All right, so coming back here to number 8. So I want to know what value, if I put in for x, is it going to make the denominator 0? So basically you ask yourself, okay, 2x cannot equal 0. So what value there is going to make it 0? Well, that means x cannot equal 0, right? That's the no-no value, if you will. So what does that mean? Well, if I don't have a graph, I think about a number line. Okay, it can be any value of x except for the 0. So then my domain statement would be negative infinity to 0, and then it would jump to 0 to positive infinity. Okay, look at the number 9 here. All right, we do have x minus 3 in the denominator. What about the top? Well, here's the thing. When you're talking about domain, it doesn't matter what the top is. You can disregard it completely. You're just worried about the bottom because the bottom, whatever it is, cannot equal 0. So let's figure that out. So x cannot equal 3 if we solve that, right? So again, think on your number line. Here's a 3. It can't be 3, but it can be anything else. So it's going from negative infinity to 3 in parentheses, and then jumps over 3 and goes to positive infinity. So domain, we're negative infinity to 3 and 3 to positive infinity. What about 10? Well, this one's weird because it's got 2 different rational parts, right? So let's do this. We set them separately. We're going to do this one over here. We're going to say x cannot equal 0. Oh, look, there's no further solving on this, right? We're good. This one, we say x minus 3 cannot equal 0. So x cannot be 3. So let's put it on a number line. So I know at 0 it cannot exist, and at 3 it cannot exist. What's that mean? If I was graphing it, I'd have to put in a vertical asymptote. Every other value for x is good. It works. So now as I write my statement, I'm going to say the domain is left to right, goes from negative infinity to 0, parenthesis, because it has to jump, right? Jump over it. And then it goes from 0 to 3, jumps over 3, and then it goes from 3 to positive infinity. So notice this. Notice that my number line has been broken into 3 parts. And my domain statement has 3 parts, right? It's a way you can check yourself. Let's look at number 11. Again, we're focused only on the denominator because that's where the x's are that matter. So here comes in that factoring business, okay? So x squared minus 2x. Well, it cannot equal 0. So let's do some greatest common factor. What do these two have in common? X minus 2 cannot equal 0. Well, in this case, I'm going to separate them out. X cannot equal 0, and then x minus 2 cannot equal 0. So we're kind of back where we were, right? So that means that x cannot be a positive 2. So number line, I'm going to have 0, and I'm going to have a 2. Can't be 0, can't be 2. It can be anything else. Those are the 2 values that are going to make us try to divide by 0, and we know that's a big math no-no. So we read from left to right, negative infinity to 0, jump over, 0 to 2, jump over the 2, and then we go from 2 to positive infinity. Number 12. Okay, here's the factoring. Again, this 5x in the top, we don't really care. It's not going to create a scenario where we divide by 0, so we don't care in this problem because all we care about is domain. So let's take this denominator and factor it, okay? So again, we're asking ourselves what 2 numbers multiply to negative 28 but add to 3, the middle term. So let's think. What 2 numbers multiply to 28? A 7 and a 4. I need a positive 3, but I need a negative 28. That means these 2 guys have to be different signs. Well, I need a positive 3, so 7 minus 4 gives me 3. That's what I want. So then I'll have x plus 7, and I'll have x minus 4 cannot equal 0. So I'm going to separate them out. So x plus 7 cannot equal 0. X minus 4 cannot equal 0. All right, so that means that if I solve it, x cannot be negative 7. X cannot be a positive 4. So number line it. I have negative 7. I have positive 4. Have to be open there, but everywhere else works. So left to right. Negative infinity to negative 7. Negative 7 to 4. And then 4 to positive infinity. And I need to put domain is and box my answer. All right. That is it. That's how you find domain from an equation. It's really not that bad. Hope it makes sense, and we'll see you in class.